It's time to rip into the latest victim, a Bosch PS60 reciprocating saw, which broke recently. This is going to be a little quick and dirty compared to some of my other teardowns. That's because this saw belongs to a friend of mine and he wants it back to try to fix it. So, what is the problem? When you pull the trigger, nothing happens and this light flashes. The manual says that's the stall protection to keep the motor from getting burned up if the blade gets stuck, so it looks like something in here has seized. The tool itself is made in China. The battery pack here is made in Malaysia. I'm going to go out on a limb and guess that the cells inside come from Samsung's Malaysia facility. When we get it open, we'll see if I'm right. To open this up, you have to pry open these little tabs. It's a little tricky to get all of them at once. I very carefully peeled back the paper here and look what I found on the cell. These are in fact Samsung cells, but I'm not going to claim victory on my guess because these are not marked the way I expected. What I thought we would find is SDIEM, which stands for SDI Energy Malaysia. The fact that these are just marked SDI makes me think they were not made in Samsung's Malaysia facility. Bosch does make a lot of tools in Malaysia, so it's possible these Samsung cells were made at a different facility, then shipped to Malaysia and supplied to Bosch. The buddy of mine who gave this to me fully admits that he abused the hell out of this thing just because it was so convenient. He was telling me about this project out in his backyard where he was cutting posts, he was ripping sheet goods with it, stuff you probably shouldn't be doing with it. He said it died partway through cutting a 4x8 sheet. I got the gloves on because I don't want to impale myself. I got all the screws out, but there is a little clip here holding the two halves of the clamshell together. There it is. Let's see if that is everything. Well, it's a lot easier to take it apart if you actually remember to remove all the screws. Third time's a charm, maybe? It looks like this sticker here is holding the two halves of the clamshell together. Finally! It looks like we have some good quality materials here. PA6 GF35, so that's nylon with 35% glass fibers. Most of the time you find 30. This is nice and stiff, highly detailed molding. Everything looks good in there. You can see these tabs here where the overmolding is held in place so it doesn't peel away as easily. The overmolding itself is SEBS, which is a type of rubbery thermoplastic elastomer. Now that we have this open, what do we see? Well, the first thing that catches my eye is how much metal is in here. The entire case for the reciprocating mechanism here is cast aluminum. With how much plastic we see in cordless tools nowadays for things like gear cases, I am pleasantly surprised to see all this cast aluminum used. Another thing I'm happy to see is a big, beefy bearing here. This is a 6002, and it's a sealed bearing, which is nice. On sealed bearings, the seal makes contact with both the outer and the inner race here to keep out contamination. I grabbed this bearing out of my stash to show you a shielded bearing. They're only crimped around the outside edge. There's no seal here, so this is an entry point for debris. So they used a nice big bearing here. They spent a little extra to get sealed instead of shielded, but they really used only an OK brand. LFK is a Chinese bearing company, and it's not one of the real top shelf companies where we see they have overseas factories and technical offices. However, LFK is also not one of the super generic, no-name Chinese bearing manufacturers. So this is an OK bearing, but it's not the best Chinese bearing you could get. So I popped out this little fiber plug here. I wasn't sure what it's doing. It looks like it's basically an air filter. This is open down into the mechanism and I can see grease down in there. So this little plug lets air move back and forth, but it keeps debris from getting down in there and contaminating the mechanism. We should be able to pull all the business parts out here and take a closer look at them. And that's where the magic happens. They really went to town with the Torx fasteners on this. I actually had to go to the store and buy this new Torx driver because the little tiny Torx screws in the clamshell were T8s and my smallest Torx driver was T9. I took a short break, came back, started tearing into this again, and I forgot to hit record. So let me catch you up with where I am. The reciprocating assembly here, you can see I haven't taken it apart anymore yet because this is not the problem. This is not seized, it's working just fine, it appears. This is what was the issue, the motor. This is a Johnson Electric brand motor, which is a name brand, but this was totally seized. You could not turn the pinion, the rotor in there was just totally stuck. I started tearing it apart here. I took off the rear cover plate, which we can see does not have a bearing, just a little tiny bushing in there. And then I pulled out the brushes here and the brush holder. They all look fine. So now it's moving a little bit, but something is definitely not right in there. And hopefully we can figure out what it is with a little more disassembly. It turned out there was not an easy way to open this without destroying it, so I took out the big guns. There are several nice details in here. There's epoxy reinforcing the windings and where the windings connect to the commutator. My friend said he ran this tool hard before it died. That made me think the motor would be cooked, but it does not look overheated. Here, I think, is the smoking gun. This gouge seems to indicate something in there dug into the rotor and then stopped it from turning. The problem is, I cannot find whatever jammed it up. There was no obvious place where something had broken free, so I'm wondering if a chunk of something happened to fall into the motor and caused this. Even though the motor was the problem, it does look well made. Nothing too fancy on the grease here. We can see it looks like a pretty basic type of lubricant. However, there is plenty of it, and it's where it needs to be. It's been clearly lubricating this gear here, this pinion bushing, and the other parts of the rotating assembly. Now that we have this open, it's clear why they use such a big bearing in this mechanism. You can't have a main shaft going through the center of this gear, then have that shaft supported on both sides, because obviously the shaft would interfere here with this reciprocating mechanism. So what they've done is there's one big bearing on the backside that does all the work supporting the gear. Here we have a little solid bushing that rotates as the gear turns. In a perfect world, I would like to see a bearing there, but I think I can see why they did not use one. This is such a small mechanism that you'd have to have a teeny tiny little needle bearing there. We've all used reciprocating saws. Imagine, for example, if the blade gets caught in the material you're cutting for a second, and the whole saw is just hammering back and forth on the material. That equals a lot of load on this pin and this bushing. And I suspect the little needle bearing would not be able to handle that. I cleaned the grease off the gear so we could take a closer look at it. We can see this is a fully machined gear. There are machining marks here on the face where it was turned, into the teeth where they were cut, and around on the back side of the gear. And they are very clean and consistent machining marks. It looks good. This is much nicer machining than we've seen on some of the cheap tools I've taken apart. Here is the main shaft that actually drives the blade. I had to look at it really close because at first I couldn't tell if it was very finely turned or ground, but the more I look at it, the more I think it has been ground to get the outside final dimension. This collar was obviously ground based on the marks we can see here on the outside. This channel's cut in the middle. This and the collar are what allow it to go in and out, but not twist. There's a post on the inside of the housing that fits through this hole here, goes through the channel. So like I said, it can go in and out, but it won't twist, which would interfere with the mechanism back here where it connects to the gear. This U-shaped piece on the back of the shaft is what rides on the pin on the gear and actually drives the shaft in and out. This is two pieces that have been welded together. I don't know if you'll be able to see that in the video, but that must be the teeniest, tiniest welding robot connecting these two pieces. We have up here on the front this felt O-ring, which is helping to keep out contamination. This would keep out big things like, for example, sizable pieces of sawdust. But if you were doing something that created really fine dust, I think it might be able to get past this seal. Here's the circuit board. I'll be the first to admit that I'm not an expert in electronics, but I see a few interesting things. There are a couple rectifiers here, and we have a chip serving as the brains of the operation. On this side, we have a sizable copper heatsink. I don't want to damage anything taking it off, but I poked around under it the best I could to see what I could see and scraped off a little of this adhesive under here. And what I can see are some capacitors over here, and on this side, what looks like a MOSFET or something similar. That would make sense because a MOSFET or similar type of transistor would generate heat, which is why you would need the heatsink here. So the MOSFET is a switch turning the current off and on. Likely this uses pulse width modulation, so that would be turning off and on very rapidly to control the motor speed. There's also a brushed on conformal coating here to help seal the board and keep out the elements and contamination. That's an extra step they added, and it's nice to see. This is a Defond brand switch, so a name brand switch. We can also see all the wire connections are soldered. They're not just simple push-on spade connectors. It probably has an O-ring in here to help keep out contamination. We've also seen on some other switches a boot here to help keep out debris. This is a brushed DC motor, so here we have the brushes. I don't know how much material they had when they were new, but it sure looks like they have plenty left. The main power wires go into the motor are also soldered connections. They did both have heat shrink tubing. I pulled it off this one to see what kind of connection it was. You know, since this broke, I thought maybe I'd find some low-quality parts inside, but that was not the case. This is pretty well made. I cannot tell if it was external debris or internal damage that locked up the motor, but I can tell you that this looks to me more like it was a fluke than some kind of design or manufacturing problem. Thanks for watching. Hit the like button and subscribe so you can see my new videos when they come out.